live and live doing done vulnerable DeFi. Today we're gonna hack together that's CTF. So CTF is capture the flags. Some challenges where you need to practice security stuff. I did that in the past. I don't know. I don't remember what's where I stopped it. Maybe I stopped in wallet mining or backdoor, something like that. Never finish. So today I'm gonna finish, and we're gonna do it together in live stream. So if you don't want to see the spoiler, don't don't watch that. So probably you're gonna watch that if you are struggle in some parts and need some help to see how my thought process to crack that stuff, right? So 1 second, let me just post that in the LinkedIn. Oh, together it's written wrong, right? Oh no, just saw that and the thumbnail together. Let me take the link here, the shareable link for the YouTube. Right. Yeah, I'm gonna fix it later. Right. Let me post and let's start. So just let me check if the audio is working correctly, if everything is right. Also, let me check the chat. And my okay, that's working. Right. Maybe it's too low, right? So let me take my microphone more close here. Sorry, I move out, change the house and city. So I still try and figure out the new layout. Also, the camera here is too dark because the color of the walls. And but we're gonna make works. So Damn Vulnerable DeFi, it's a project. They create DeFi concepts, but with a lot of vulnerability inside. So we can read here. We come to Damn Vulnerable DeFi. Let me power off the WhatsApp sound here in my ear. And okay. So the training ground for security researchers, so the vulnerable DeFi, developers, educators to dive into the smart contract security. Are you ready to save the most vulnerable contracts ever coded? Explore challenges featuring flash loans, price oracles, governance, NFTs, DEX, lending pools, smart contract wallets, time locks, vaults, meta transactions, token distribution, upgradability, and more. So that's gonna be fun, right? That's gonna be a fun stuff to do. So the first one is called Unstoppable, and the instruction how to play. So find all instruction to install, play, troubleshoot any other rules in the repository. Here's the repo, and we have some testimonials. Looks good to me. Crypto writer, guru, influencer. In my days, I have gone all into these bad boys. Catch a name. Got projects and the pools. I have seen worse in productions. Nice. Here they have some updates. Good. And so using to sharpen your auditing and bug hunting skill, learn how to detect, test, fix flaws, reality scenarios to become a security-minded developer. Benchmark start content security tooling, create educational content is smart content. Oh, that's benchmark start contract security tooling is a good idea too, because Trail and Bits, they just release some skills they use in Cloud Code, and we can we can try that one too. So Trail of Bits, they have Critic, where they focus on Web3 stuff. Where is, I think it's in the trail indeed. Yeah, that's one skill. That skill here. Yeah, we can add it. I think I already had it. They have auditing contest building. They have perp suite project for pen testing and Web2 stuff. Differential review, security defaults, Ingram rule, and a lot of other stuffs. But for some reason, I cannot renew my Cloud Code. I don't know what's happening with the Cloud, so maybe another day. So let's start with the Unstoppable. So Unstoppable, there is a tokenized vault with 1 million DVT tokens deposit. It's offering flash loans for free until the grace period ends. To catch any bugs before going 100% permissionless, the developer decide to run a live beta in testnet. There is a monitoring contract to check liveness of the flash loan feature. Starting with the 10 DVT tokens in balance, show that it's possible to halt the vault. It must stop in offering flash loans. Okay, so here is the test you can see below here is the test for solving and the problem using Foundry, right? And that's the contract we need to hack. And it's so long I don't use IDEs, but I have installed Zed. I was working the capital stuff, right? That's safe to share. Let's close all stuff and let's open, let's fork that stuff, right? Let's go number 2 for that one. Let me just okay, so I think I can fork everything, and I hope I don't have answers here. I think I already have the answers here. I don't like that. Okay, but okay, let's try create a new folder for us maybe. So we have a lot of ways to fork. That one I like it. So let's open our warp. Let's go to projects. And here, project. I think I already have something for the there. So I already has. Oh no yet. Yeah, so that's what I did in the past. We can see here the dates when the first try was April 23, and the last run was January 28. Really? Huh. Is that right? Let's see with the Nautilus. Oh, 25. Okay. Yeah, the last year. Makes sense. So I probably downloaded here and the last run was here. Maybe I can figure out where I stopped later. In here I have some tests, so I have levels. Oh, maybe that one's all I did. Looks like yes. Looks like not. Okay, I think they change. Okay, let's download new version, right? Because they change a lot of stuff. They maybe improved. So let's download. Let's go inside and let's open Z. I don't like use dev container. I mean, it's cool to use, but I never really use what they have here. Cool. Yeah, it's kind of cool to use. Let's try use the Docker. Here the dev container. All right. And unstoppable. So we have two contracts here. The best idea to auditing big contracts, in my opinion, it's IntelliJ. I don't know how. I don't have it here anymore. IntelliJ idea. I don't know. I don't have anymore. I remember. I think I have a problem with the workspace and that was erased. Anyways, so because I'm trying to test and with Z and that ID written Rust, let's see how they have Solidity in here. Let's go try extensions and go nomic Solidity. They don't have too much options. Okay, no problem. That's gonna run, right? That's gonna be executed. If we go foundry test. What? Oh, Forge. RT. Yeah, long time I don't use. Vibe code so much. I don't remember the commands. But yeah, they're installing all the dependencies here. Luckily, they're gonna open and work after they finish. So we have two contracts. Here they say permissioned contract for on-chain monitoring of the vault Flashland feature. The contracts extend from owned and the IRC 3160 flash borrower. We can study a little more about. And we have the constructor and we have some functions, right? I think maybe it's good to go to VS Code because VS Code has a lot of good extensions. Let's try manually first. So on flash loan, I think that one is from the implementation here. We can go check. That's from OpenZeppelin. Create a standard for flash loans. So flash loans, how the name says, is to loans, allow you to loan something, and but you need to give back the loan in the same block. Tell me about this free money. Yeah, basically it's a free money indeed. Paying some taxes for using. If I could keep my flash on longer than one transaction, that would be great. Yeah, And what is AAP? Flash standard. So they create a standard. The lender interface must be implemented by services want to provide a flash loan. The functions max, flash, and flash fee, they are pretty self-explanatory indeed. So max, we have flash loan, flash free, flash fee, and what the flash loan function will be. Oh, that's the lender. Okay, we need to see the borrow. So okay, I think the borrower gonna be the lender gonna be in another, right? Let me close that. Where's my Z? Right, it's not the right place. Okay, now it's in the right place. So let's see the vault. So the vault has the lender. Yeah, makes sense. So that's the lender, that's the borrower. So the borrower give the money, the lender take the money. So here they say the RC on RC 4626 is the vault compliant tokenized vault offering flash loans for a fee. An owner can pause the contract and execute arbitrary changes. Right, so you can see they have owner, they have the vault, it's pausable, they have an owner, they have the hand guard, and they have the flash lender. So that's the vault we need to break, make they stop. So we see they're using the safe transfer lib from soulmate and fixed point from soulmate, fee factor 005 at ether, grace period 30 days. The end here is the block timestamp when the block was deployed plus grace period. So that's gonna stop working in 30 days, right? Right, so they asked us to make that stop working, right? Let me check here. Developer decide to start with the 10 DVT tokens in balance, show that it's possible to halt the vault. It must stop offering flash loans. So you can see here, probably if you go further the timestamp, they're gonna stop, right? So that's something probably we can hack. Let's see. Need to see the implementation. And see here we have the fee recipient, or it means the address is gonna receive the fee. We have some errors, the mother errors. We have the events, and we have the constructor. So in the constructor, we have the token for the vault. They call DVT, and we have the owner of the contract, the fee recipient. Then we have the functions, right? So how they was explaining here, we have the max flash loan. So with the flash loan function, that one, we will be able to execute the flash loan. The receiver address must be a contract implementing the borrow interface. Any arbitrary data may be passed in addition to the call. The only requirement on the implementation details the function or that you have to call on flash loan callback from the receiver. So that's the only requirement. And the result of the function need to be key check on that string. So that function, okay, that's the implementation of the flash, all right. So let's see. I'm trying to understand here the pattern from the ARC 3156 first. Yeah, here they have the return, right? So here I need to check. Here I need to check if they return what we need. All right. Here they're using I, and here they're using I. Okay, that's right. But here it's another stuff, right? Yeah, that's a different one. But don't matter. They just need to be the same. And all right. So how the flash loan works here? So we have some amount. So if the amount is equals 0, it's invalid. So that's accept 1 and beyond. If the address asset is asset address is different from token, that's not supported. So they make sure that the token asked to be need to be the asset where the asset's defined. Asset is defined. I think it's internal, right? Here, probably. We can, oh, nice. That works off the box. Yeah, so you can see here, asset is immutable and it's decided in the constructor. And here we have the constructor called token. So the token is asset. And the token probably is the DVT. And then they create another called TDVT. All right. The max flash loan here for the token, if any token different, it's gonna be 0. So you cannot loan. They did not give you error. Did not revert. Just return 0. And here they give the total assets. That's also implementation from the vault. Great. And that's virtual here. So that's missing implementation, right? So I need to implement total here. The asset balance of address this. So just check if the amount the balance from these. They have non read reentrance. So that's avoid hindrance read only, right? Cool stuff. Cool stuff. Guard the view function from read only hindrances. Nice. That's efficient read, right? They check if the address of self it's in the slot. If it is, so they have a reentrance, so they put in the memory store and revert. And when they add that, I think it's here, store. Yeah, cool stuff. Why they are, oh, they now say memory safe. Cool. All right, and where we are in flash fee. So the fee is different. Again, the difference is not supported. So try return the fee in the token that not exist. They're gonna revert. Not accepted. And here they check for the end. So they check the current timestamp. It's the less than end. So if it's not there yet. If the amount also it's less than the max. So see if it's not in the end yet and the amount is allowed, they're gonna return 0 fee. Oh, okay. If that's greater than the grace period and greater than, or wait, that's not right? So to get here, I need to fail in both because that's E. It should be false and false. So the amount should be greater than the flash loan. And they need to be that need past the 3rd day's grace period. To then take the amount and multiply by fee factor. That's very strange. and using the WAD, I don't remember the WAD means, but they gonna calculate the decimals for us. That's from soulmate stuff. And that's a little strange, right? But okay, let's continue. Normally, what I can do is go to I think it was audit. Wait, audit note. I think it's like that. They said no fee for flash loans within the grace period. Yeah, but and amount it's less than flag. Yeah, in here that's good. Now gets strange, right? Fee calculation for flash loan outside the grace and amount greater than the max. So the max here is it's saying that if I have a flash loan greater than the max, and it means it's some case where they're gonna miss the boss return, right? Or crazy. I'm crazy. So for example, let's say that's false, that's true. Okay, that's gonna be here. Yeah, of course. I'm crazy. So if the max loan and the end that's finish, they're gonna need to pay. Okay. Yeah, so that's basically the grace period here. I cannot probably not using that one for nothing. Flash loan, I was already here, right? So here we take the balance before the total assets checking balance off for that contract, and they need to convert the shares. That's also from the vault implementation, if I'm not mistaken. Yeah, for some reason not working. No, I forgot what's the key shirt to back. Control O. Oh, my face is not in the place, right? Let me go here. Maybe I can close that one if I remember how to do that. And get a little greater. All right, so we convert. So total supply, if converted share total supply is different from the balance before, we invalid balance, right? So they take the total supply, check the shares, and check if that's different for the current balance. That's basic current yet. Otherwise, they're gonna go invalid. Transfer token out plus execute callback on receiver. So take the token, transfer from this to receiver plus amount. So the receiver that's gonna receive the flash loan with an amount, the amount asked, and callback must return magic value. Otherwise, assume that it failed. So here we take the fee, it's gonna be 0 or something, and call on the receiver the flash loan. So who is asking for the loan need to implement the receiver and return that on to be accepted. And then after the calling, they're gonna pull the amount plus fee from receiver, then pay the fee to the recipients. They're gonna take and transfer from receiver to these. the amount back plus the fee, and that safe transfer from means that I need to accept first, right? Allow that contract manipulate the token for me. And here, that implementation is a little weird, right? Because back in the days, what do you do? It's like inside here, you do the transfer back. And here we have a require to check if that was correct and then revert everything else. Maybe that way it's more safe. But then you need to do a proof, right? To be able to use that. And here we transfer the fee that received here to the fee recipient. That's another contract. Can be the same contract too. I don't think it can be, because if this fee is paying the same token, they're gonna mess up the balance here. Okay, the only I still need to understand better is that one, but I don't think it's needed to understand now. Then here we have the set fee recipient. So see if the fee recipient is different than this. So yeah, so that's a good check to avoid mess up the balances, putting fee inside. And here allow owner to execute arbitrary changes when paused. So only when that's paused, only owner, we can call any target, any function. Okay. And here we can pause. So here we can flag pause and flag unpause. If true, pause, false, unpause. And when it's paused, we can execute something. Only owner. Only on includes, we can like execute pause here with execute, but we need to be only owner, and I don't think we can change owner, right? Owner defined once. Maybe it's the, no, that's the implementation from soulmates. That should be safe, I assume. So right, they changed a lot. And the first version of the unstoppable vault was different. I'm almost sure that the first version didn't use let's go source unstoppable contracts. Yeah, I think the here unstoppable. Yeah, they call receiver unstoppable and lender. I hope I don't have that solved here. It's not spoil. Let's open text editor. Why not? Yes, was that the first version? The different here, they have only hand trans token. They have a pool balance. It was more simple, right? Very simple, the first version. And you can see here, they have the checking, like I said. So they call the transfer to borrow, and here they call the receive token the receiver, and then they check if the receiver give back, otherwise the flash one was not being paid back, and then revert everything. And then we had here just deposit tokens too, where we transfer some amount for the pool balance variable. And here we have the balance before came from balance off, and here in the transfer, yeah, and known hindrances, right? And they have the receivers that was also simple with the function where they just transfer the tokens in here called execute. Right. Cool. So I of course don't remember how I solved it in the first time, but then we need to figure out how we're gonna solve that. So let's read again the prompt. So to catch any bugs before going 100%, developer decide to run a live beta in testnet. There is a monitor contract to check liveness of the flash loan. So they call monitor. That's the monitor. They have the vault here. And they have the status. And that's also the borrower. I mean, they have the borrow here. And yeah, they prove it here. So on the flash loan, I need to approve to the vault, take the money back. And it should be have fee together, right? And here, if the initiator itself, if the sender, no, if the initiator is different, is the sender calling that different from the vault, the token is different from the asset, or fee is different from 0, so it's an expect flash loan. So they're expecting some fee. And here the checking flash loan. So require the amount to be greater, the only owner. And here they call try vault flash loan, because the vault here is that implementation, right? Because the pure implementation don't have that kind of functions. They have just deposit, withdraws, the assets, the name symbol, and the deposit to the calculation for shares, and the mint. They use like another token to have the shares. Here they withdraw, to redeem, they convert to shares. So take the total supply and divide, multiply and divide down. Convert assets, max, mint, etc. Right, let me close that one and that one. And here they call flash loan. So again, flash loan, it's here in the check. And the D's is the receiver. So that one I'm gonna receive. The asset, it's the same as in form. The amount, any amount we want to check. And they have some data here. I missed that one. Oh, the data I missed. The data go inside here. The data can be inside the receiver. And if they're gonna here call data, I can do whatever I want. Oh, Hmm. Can I use the call data? Oh, that got more elaborated. So can I get the call data to execute in here? Wait. And change the owner, no, right? Who is the owner? What? So the owner here, we should be creating founder, right? I was thinking that we're gonna solve that just in our minds, but it's clear to me that cannot be solved in that way anymore. I don't want to open here get spoiled. But I want some example. Maybe I can use AI to take without showing us. Okay, let's go new folder. Unstoppable us. In here, let's go unstoppable us T sol. I hope the AI don't give us the answer, right? And I don't remember how to import stuff here. Okay, let's go contracts. Yes, it's not TD test anymore, I think. Oh, it is. Pragma, nice. Import, nice. It's Alt L. Oh, oh. Okay, calm down. Otherwise, they're gonna finish for us. Okay, here, let's go. It's TS test. I think it's not, right? TS test is old. Okay, rear. Let's, yeah, that's the setup. We should be having unstoppable. It's not us. Nice. In here, yes. I think it's missing a lot of stuff. So token. I need to create the DVT token? Really? They don't have the token here? Oh, they have. Okay, they have the DVT token. Nice. We have a README here too. Nice. So let's start with 10 DVT. So here, then valuable token. That's the token. That means then for that address, and then here we go token address and what it is. That don't make any sense. That's a fee recipient. Can be added this too. Owner can be added this. So added this, I think. Should be okay for now. No. He thinking it's okay. Right, let's test Forge T. They're gonna run everything here. Oh, nice. Can I open? I think that's, oh, that's nice. That's failing. Okay, so it's safe to open here. Great. Okay, so I thought we need to create all the tests, so we don't need it. Great. Okay, they have the challenge here already. So yeah, I have the token in the vault, the initial player token balance. Okay, how I power off the copilot here? Um, how I power off stuff here? Powered by Zeta. Um, Display prediction line only when the holder modifier out by default. Okay, that's good. Yeah, so if I call out, okay, and out, oops. Oh boy. Oof. Okay, so they created some fake address for the deployer and from the player. So if I run, so let's delete that one. Let's copy to keep Rust, and here we can go tests, and we can go VVV if you want, and I don't remember match test. No, match class. Unstoppable. They're gonna fail because of that. So they're gonna run only the unstoppable. They're gonna they need to give some fail, right? And here we can see all that stuff happening. Okay, so the token, we have 1 million tokens in the vault. The initial player token have 10, so that's us. That's us, the player. The damn valuable tokens here, the vault is here, the monitor here. And how they set up. They start hoax. And I don't remember the hoax does. They use the deal. And they start prank. So now basically we are that address for until stop happening. What the deal is giving some balance, yeah, giving some balance. That one shift sent 110 to 8. Don't remember how much you're gonna give me. You're gonna give me half of what the 256 has, right? You can confirm that. Also, we can confirm what the casts, or no, it's not cast. How the what the chisel? I think with the chisel is the best to confirm. Chisel. So 1. Yeah, you can see when we go half, we get half of the full, and that's a big number, a lot of stuff. All right, I still remember that stuff. Good. Okay, so the gods, the deployer, and here they are calling the constructor with the constructor parameter name, it I think it's called, where we don't use order, but the name is then if you create more or change the order, the code don't break. So token deployer in the deployer also the fee recipient. Nice. So the vaults here, deposit tokens to the vault. So they're gonna approve the token to vault and put the tokens there. And wait, the tokens approve icon, allowing the vault transfer the tokens, and here the vault depositing the same value. What's deposit this? Did you see the implementation? Because I don't really remember why they have the address here. It's the owner. Here as the receiver. For the shares. Okay, makes sense. Yeah. Right. Here also we can, I think we can go like y proof here answer how to approve the approve the vaults here to spend the tokens on behalf of the player. I think because inside here the deposit they need to call transfer from who calling. I need to transfer before minting. Yeah. Cool. That's why. Fund player account with initial token balance. Fund player account with initial. Yeah. Okay. So the token transfer and probably from that contract. Give initial. Strange. Let me see what the transfer here. It's normal transfer. Yeah, it's the normal transfer. So the transfer is normal. It means they taking the amount we have here because here they mint the max token possible for the sender. So that contract test has the means to transfer for anybody. They did the 10 tokens we have, and okay, that's all the deployer address. Indeed, it's not the contract. Indeed, it's the deployer has the tokens. And here they stop the prank. I don't know why they didn't stop. Why they didn't stop walks? Maybe because they don't exist. And deploy, monitor, contract, and grant it vault ownership. So here we pass the vault and transfer the ownership to the monitor. So the monitor now is the owner. That's important because that execute functions and pause functions can be only executed by the monitor. And the monitor don't use call data, right? Oh. Oh, what the hell? Try flash low on true, otherwise false, pause and transfer to owner. What? Okay, that's very confusing, but let's see it later. It means if you try flash low on and get any error, we disable the status. We pause and transfer ownership to the owner from the monitor. So the monitor is the owner. If something bad happen, the owner of the monitor gonna be the owner from the vault. In that case, it's who create the monitor, and based on that, here is the deployer. Hmm. Yeah, so here the vault get the ownership owner being the monitor contract. The monitor check if it's possible to take a flash loan. So here we expect some event. What event we expect? Oh, they changed that now. Cool. Beautiful now. Very beautiful now. We expect that events. We can go multiple events now. I cannot open. We expect to see wait. Flash loan true working. So we call check flash loan with 100, and that should be working. So the setup should be working if you run. It should be working. So now some initial condition need to be checked here. They have then the solution need to paste here. And here check if that's solved, right? So we don't like to see that yet because they're gonna spoil exactly what we need to do. Let's try understand first, then we can get some hints here based on the conditions. So what's check solved by player means that when the test being called, they gotta start prank player. I don't remember why 12 two times. Anyway, execute the code is drop and then check if that's solved. Okay, they're gonna do the checking. Nice, beautiful and elegant. Very, very elegant way now to check stuff. All right, so what's the initial state? So the check initial token balance, when that's executed, I think it's in order, right? Because here, that's passing. So what they check if the balance the vault has the tokens. They check if I have my balances. They check if the monitor has an owner, is the deployer, the monitor. They check if the vault has the current token. The total assets is the token. The total supply is the token. The max flash loan is the token in vault. The fee, if the fee is token in vault less 1, 0. That's right. Okay, yeah. So okay, they checking the return of the function, right? Remember? They check grace period and the max value allowed. So the check here should be 0. And if that's greater, they need to return the value multiplied by the fee, I think. Why they don't use the variable fee here, I don't know. Okay, we can check that because that's 1 million, right? And the fee value is 0.005, should be 50%. I'm guessing here. Or no, that's 5%. because 1 million 5% is 15,000. That's correct. So if you ask for tokens that's inside the range, we don't have fees to be asked. But if you ask for something equal, or it means greater than the max loan, so we're gonna be charged 5%. Even if you're inside the grace period. So the grace period inside 30 days have the max loan too. So that's the requirement, the restriction. Right. And the vault, it's owned by the monitor account, exactly. So the vault, it's also owned by the monitor when they do the transfer here. Now we can draw that if you want. That's some cool practice with more complex contracts. You can go here and draw. What? You can go here, draw. That's why it's too little. We have the vault. Maybe let's. We have the vault. Maybe we're gonna give a zoom. Yeah. We have the monitor. We have the deployer. We have the player. That us. Wait, I'm missing something here. What's the third party here? The vault was owned by the deployer. The monitor is owned by the deployer. The vault, the deployer transfer the vault to the monitor. I think it's the 4 parts. Yeah. The vault it's now paused. Cannot pause the vault, so that's cool. So I think it's the deployer testing here, or there is the contract. The contract or anybody is trying to set the pause that need to be unauthorized. Cannot call monitor contract. True, because only who's the owner, right? In that case, only the deployer can check the flash loan. So we can do some draw here if we want, like 5. We can go owner of monitor, and monitor it's owner of vault. So the check-ins here, and I'm nobody here. So now we need to break stuff. Okay, so let's go back to the monitor and see that suspicious code here. So only owner can call that, right? So they said the check flash loan, it's called time to time, right? When they call they try to do the flash loan. If they revert, they pause the contract. So that's only thing we need to do, right? Just need to pause the contract. If we go back to README again, so start with the NDVT tokens in balance, show that it's possible to halt the vault. It must stop offering flash loans. So basically, when you just provoke get in here. So I don't know how and when they're gonna call check flash loan. I don't know if you can, if we allowed to out here. So yeah, so they're gonna in the solved, they're gonna call the flash loan for us, the deployer, right? And that need to be paused, and the owner whatever. What they need vault did not change the owner, and now they want to pause the vault and transfer owner to deployer. Oh no, that's correct. The deployer, yeah. Wait. Yeah, that's correct. The message is not right. Okay, the message is one that is not right. Okay, yeah, yeah. If that's paused, it's a normal message. If it's not paused, they're gonna do that message. If that assert fail. Yeah, so they're gonna call flash loan for us. So we need to break based on the vault flash loan. Here we have these as receiver. And they have called data nothing. Let's go to default then. What is, let's close that one. Let's close that one. That's closed. Now that's what we are using. Test. That don't need it anymore. That don't, let's keep it, that one here. So he called flash loan. Let's see, we have data here. I don't think we have data here. Yeah, so here we can revert, right? No, we cannot revert because they call that as empty string. But here we have the way to revert. Oh, the simple way to revert is just not giving him back what they want, right? They're gonna revert. If that reverts, they're gonna break everything. So that's simple like that, right? Because we can call flash loans as no, that's not so simple. So we can call flash loans manually and pass receiver at us. We can create a contract that receive the interface to be able to get that function call. Then we can return something to fail. That's gonna revert. No, that's not right. Wait. No, we need to do inside here. So the vault call flash loan, passing these. Here, these gonna call here. And they call approve in the token. Just approve. Approve the amount. I can now modify the token contract. The return is fixed. Okay, here I can make a break, right? or not. Fee different from 0 here. So if the fee is 0, I can make that break. So I cannot change fee, right? Fee it's past where? Wait. Inside the votes. Fee here. If I go 0 here, I break everything. And to be able to change the fees, the only way is getting both true. Right? So if that's true, no, if that's false, anyone false is gonna be 0, right? Basically, if the grace period pass, they're gonna halt. So I don't know if the question is like we need to just wait for 30 days. Don't make any sense, right? So we just need to wait. Don't make any sense. So it's possible only possible. Can you revert it to? Let me see. I have 10. I have 10 DVT tokens, right? I can change the balances. I can revert here, maybe. Because if the convert to shares for the total is different from the balance before, I just need to add some money inside the vault and they're gonna break, right? So the convert shares, why it's not opening? Okay, let's go in the vaults. Here. Convert, oh nice. Yeah, saves an extra as a load if total is non-zero. So if the supply is 0, return the assets. Oh, it means the number defined here. Otherwise, divide the assets divide down. Multiply the assets per supply divided by total assets. Total assets was implemented as total assets as asset balance of this, where we can do some check-ins here, right? We can go like vault total assets, wins total assets. What? Wait. Yes. And I don't remember how to print. Console log. Wow. don't want everything, but okay. Total assets. No, no, no. Oh, that's better, I think. No. Assets, total supply. Max loan, why not? Fees, why not? Let's run to check the values. They should be. Why? I need to save. That's saved, right? Very strange. Really, it's not saving. Wow. New wing conflict. Okay, should be here, right? Yes. So the assets, I don't care. So the total, I don't like when they do that. It's should be 1 million, right? And the supply is the same. So if you do the calculation, here, if we do the calculation here, that is supply. Can we use that multiply division stuff? Oh, we can call convert shares, right? It's better. We can call. Okay, we can call vaults convert shares. Convert shares. I think it's plural. Convert to shares. Convert. That's public. That's public. Convert. Oh boy. I don't know why it's not doing. Right, so no. I'm not use it. Virtual shares. I'm not used anymore. I'm not used anymore with the keyboard. Anything. Here should be. No, this should be shares. I think to save, I need to go S. All right. Log mismatch and param 0. Log mismatch. Log. Huh? That should be the numbers. Okay, here, shares. So that should be the same numbers of shares. Okay. So it means the total supply, it's not 0, right? Because wait, they are the so supply, it's 1 million. Let's go 100 to be easy. So let's say the assets, it's 100 multiply I divided by itself. Makes sense. Makes sense. All right. So, okay, so I was initiator. I think we cannot change that, right? Let's go back here to checking. So the owner is calling. The owner passed this as an initiator, and the initiator to be different from this address itself. So monitor cannot call flash long. The sender also need to be different from the vault. It means the vault also cannot call flash long, because flash long gonna be calling off flash long, and that can be a problematic. It means if we can make the vault call itself, that also can break stuff, right? But it's already that gonna be called by the owner. So this, what the fuck is this, by the way? Oh, because they, okay, yeah, I see. This because it's borrower. Yeah, I can modify that. I can modify that. In fact, I can change the assets values. And amount, I also don't have control. And bytes, I don't have control. So inside the vault, yeah, I need to break the invariant here. I cannot break that one, right? Because I need to be able to change the asset token. I don't think it's possible. You can check. I think the assets, it's only define the constructor here, and they never change again. Yeah, that's immutable. So that we cannot modify. That one we don't have control. And here we have control. So the total assets can be modified, right? So if we can check total assets, we gonna remember that's the balance that the vault has inside itself, using balance of this. That's dangerous. So if we just send some token here, that's gonna change. We can test here. Here we can go, we are a player, right? So we can go token transfer to the vault. I think maybe it can go like that, I don't know. And initial, they're gonna initial value, they, what's happening? What's the, why it's not working? Boy, why did not you? Okay, that's copied. Yeah, we're gonna do to, I can do it directly. Oh, nice, I can go directly. Yeah, basically it's that one. I copy that line. Here, that's we delete. Instead, what? Okay, instead here, player, we go bots. They're gonna not like because it need to be address, probably. Right? Yes. And then if we go console log and check the, in fact, I need to check here, right? Okay, let's go log. Oh boy. Why is this not auto completing? Yeah, let's check the total assets. That should be changing, right? That should be breaking that invariant there and make everything right wrong. It's not working right now. Okay, so here I need to save this. That's why. So that should be working directly, I think. I was trying to just check the logs, but maybe they're gonna pass. Yes, they passed. Because that is the older one, like you can see. So see here, the total assets changed, and that's allow we break the contract. We can see why we cannot see the calls. I think I mean the other V. Yes. So yeah, we solved that easily after sometimes 1 hour. Yeah, I think it take more time to understand the patterns there, how they get implemented. But basically here, what's happening is it's dangerous using balance off. That's a bad pattern to use. Normally, the good way to do is have a variable where you can have more control, because balance of address Ds, it's always, we can always get manipulated by outside, and that's not a real problem here, but the problem here is because we need to do the check in here. So here we have like 1 million, right? 1 million tokens, and the convert to shares do the division expecting that if you try to convert the shares using the total supply, they need to be the same as the total assets. It's kind of strange, right? Like I said before, what's the intention here? I think it's important to understand what's the intention here. For that, I think we need to remember how the vote works. I think it's that 6. Yeah. So the vaults. So visualizing security concern inflation attack. Yeah, I think we can call that it was inflation attack. So in exchange for the assets deposited in the vault, user receives a share. That's not another token. These shares can later be burned to redeem the corresponding underlying assets. The number of shares a user gets depends on the amount of the assets they put in and on exchange rate of the vault. This exchange rate is defined by the current liquidity held by the vault. If the vault has 100 tokens to back 200 shares, then each share is worth half assets. If a vault has 200 tokens to back 100 shares, then each share is worth 2 assets. In other words, the exchange rate can be defined as the slope of the line that passes through the origin and the current number of assets and share in the vault. The positive drought move the vault on the line. Yeah, that's a mathematical more for the relationship for the shares and the assets, but it's like percentage stuff. On the plotted in log scale, the rate is defined similar, but differs because the points are indefinitely far away. Rates are represented by diagonal lines with different offsets. Exactly. In such a representation, widely different rates can be clearly visible in the same graph. This will be the case in the linear scale. The attack. When the depositing tokens, the number of shares a user gets is rounded down. This rounding takes away value from the user in favor or default in favor of the current shareholder. This rounding is often negligible because the amount is on a stake. If you deposit 1 in 9 shares worth of tokens, the round we have you lose or the most 0.000% of the deposit, whatever. If you deposit 10 shares worth of tokens, because it's little, you could lose 10% of your deposit. Even worse, if you deposit 10 share less than 1 share worth of tokens, then you get 0 shares and you basically made a donation. Okay, so that's inflation tax for other stuff. It's not the same way we did. I remember reading something about it, but I don't want to know about the security. I think adding fees on the vaults. Yeah, that's something good to study about vaults, but it's not what I want. Maybe that can be explained. They already explain how it works. I'm looking for something else. Stuff. Motivation here. Let's use real example motivation to design. Let's say we all own a company or a liquid pool that earns stable DAI. Particularly the stable DAI, it's asset in this case. One efficient way we could distribute the earnings is to push out DAI for each of the holders of the company as a pro database, but it would be extremely expensive gas-wise. Similarly, if you were to update everyone balance inside a smart contract, that would be expensive too. Instead, it's how the workflow could work with the vaults. Let's say you and 9 friends get together and each deposit 10 DAI each in the vaults, 100 total. You get back 1 share, yeah, because we have 10 people. Let's say 1 share represents 10 DAI. So far so good. Now your company earns 10 more DAI, so the total DAI inside the vault is now 110. So we should be dividing that based on your share, and now we should be having 11 DAI. When you trade your share back for your party of the DAI, we don't get 10 back, you got 11. Now there is 99 DAI in the vault. 99, yeah, but 9 people to share amount. If they were to each withdraw, they will get 100 each. Note how efficient it is. When someone makes a trade, instead of updating everyone's shares one by one, only the total supply of shares and the amount of assets in the contract changes. The vault does not have to be used in this manner. You can have an arbitrary mathematical formula that determines the relationship between the shares and assets. For example, you could say every time someone withdraws the asset, they also have to pay some sort of tax that depends on the block timestamp or something like that. The vaults as standard provide a gas efficient means executing very common DeFi accounting practice. So that's the point for the share. It's like the stocks, right? Where you have a paper for part of the company, and if the company has some profit each year, you have a share of it, right? Then you can redeem. It's a little different, but the point is you have a percentage represented by a token we call share. Okay, so here they call naturalist user want to know which assets vault use and how many are owned by the contract. So there are 2 solid functions for that. One, it's asset. The asset function returns the address underlying token used for the vault. If you do underline asset was say die, then the function would return the ERC20 contracts die. Yeah, so in the total, calling the total as a function, we return the total amount of the assets managed or owned by the vault. The number of tokens owned by the contract implementation is quite simple. Yeah, balance of address Ds. So like I said, that's dangerous, but it depends how you checking, because people can modify that, right? Depositing more stuff like we did here. We deposit some token to the vault directly. I think the vault accepting some deposits. Let's see. Here you can preview the deposit before doing. I think you have deposits function. I don't remember. Before withdrawal, after the deposit. Yeah, I think here you can call deposit function here. So that should be the right way to do, because you call deposits, and I don't remember how they works, but let's try and figure out. Check for rounding error. This we run down. It's in private. So here's the number of the assets you're depositing. Let's say it's 10. So that's the token. So if I put in more 10 tokens inside, I need to receive shares, or at least numbers of shares. I think they're gonna mint. Yeah, they're gonna mint shares for me. And we see here, if you use the deposit function instead the transfer, let's go vault deposit. I think I can deposit, right? I think I'm allowed deposit. Yeah. So who gonna receive the share? Gonna be this, I myself, and assets gonna be almost everything I have. In that case, initial. Oh Jesus! Oh my goodness! Okay, yeah. Right. So if I save, well, let me try test something here. That works. Okay. And run. That should be fail the test, because I think they're gonna works as they should be work. Okay, that's transfer failed because I need to approve probably. Yeah. Wait. Underflow, overflow. Oh, because I think they check for the limits, right? So transfer from player. Okay, transfer from player. I have 10 tokens to the vault. Oh, that's not right. Oh, that is. Why it's. Oh, okay, that's 10, right? 10, that's. Let's say I don't have probably. But I have. Okay, they check the balance. They have a lot of balance. And here, transform player. Let's see how much I have. It's console log. Player balance. Okay, we solved the problem. I want to just make sure if the deposit works, I expect it. We should be ending the live, but I'm curious. to know. Okay, so let's check here in the logs. Yeah, my balance is 0. Why? I'm transfer? Why is my money? What? Where is my money? Token balance of address this. Address this. No, wait. Oh no. Wait. Really? I need to put address this. No, don't works, right? Need to be player, I think. It still don't make any sense because the post should be called by sender message sender. Let's see. Okay, now it's the right. But it is failing the deposits. Okay. So it's failing. Need to transfer before minting. The tries transfer from myself to the vault, the number of assets I have. So that should be working, but it's failing. Here. So how much the balance of the vault has. I think is the limit here. So I try call deposit with the 10. And here, when they try transfer from, they panic. Let's see here. That safe transfer from is from Soulmate. Soulmate is gonna be also in all in assembly, but they are doing underflow, overflow. Strange. Very, very strange. Okay, let's see the transfer from Soulmate. Transfer from. Yeah, that's terrible to understand. Terrible. Very terrible. It's not even not using the path the not correct, but the safe assembly memory. But here they are doing the transfer, and how they are taking panic. To get a panic like that. That should be failing. That's no panic, no panic, no panic. Wait. Equal can no equal cannot adding. What the hell? It's the call. Panicking. Wow. Okay. We have a limit. Don't make any sense, right? Convert it to assets. That's a way to know how much asset you're gonna get back based on the share we have. Here's the preview. How before depositing for sure. Here the max. No, but the max is the max. What the? Wait. Maybe we implemented it here. No, we don't have max implemented. We have after, before, not implemented is set fee, execute. Really? Very strange. Anyways, maybe that's for another day. The point is we break the contract doing the transfer, break the invariants, check in there. And here, so what they try to do here is check the total supply. That is, I think this should be the same of total assets, and try to convert it. It should be equal. Enforce a requirement. That's a requirement. That's a requirement. Strange. Okay, let's see total supply. Wait, that's from the token? No, don't make any sense. They have, oh, of course. So that token is the T, the share. So that total supply is the share. Bad name, by the way. So convert to shares. That's very wrong, right? Because here we are expecting assets. He's putting, so let's say we have 10 share across the 10 people there in the first example. So if I try convert the shares based on the balance, that's gonna fail, right? Yeah, that's very strange. I don't know how what they try to do here. Can we ask to AI? I don't remember if I have way to inline assists. I need to configure. Cloud Code is not working. I don't know why. I think I have codecs. How I can use codecs? Let's configure already. Start a new thread. Yeah. Can I? Yeah. Here is a vulnerability. Why? He said, let me enforce 86 if total supply means that the number of shares, right, and total and try convert to shares. Okay, let's see what they. Okay, nice. Okay, here we can use GPT Mini for free. Okay, put maybe Claude Haiku. Okay, he's checking for us because I think it's important to make sure to understand why they did that and why it's enforcing. It's a requirement and what's the right way to implement it, right? But was a fun review from Unstoppable Vault. Damn, take too long. Okay, so short answer total. Indeed, is number of shares in convert to expected amount of the assets. Yes, that's the problem. It's intentionally weird. It's forced the invariant the total shares. It does that because and how it's defined. The invariant is stronger than the normal requirement. It's used to do here to detect or reject any out of band changes of the vault balance. So explanation mathematician. So let's see as total supply assets. The conversion of asset share assuming a simple proportional conversion. Exactly. I said percentage, but proportional is the best word. The vault calls, plugin, etc. So to check is the check for S equal to A. In other words, the number of share must be equal to the number of the assets in the vault. So that's what they try to do. That they try to do, but it looks wrong. Why not use convert assets? Instead, convert asset share return the number of assets that correspond to the share with the same proportional logic. That will always equal to balance before by definition, so it will not detect any outbound asset transfer. It's a tautology. Check and expect the changes. Why the comment say enforce? Why it's misleading? Requires consistent conversions, but does not require S equal A. Many validated vaults have a known one-to-one share price. Yes, this checking force has stricter vaults invariant. The comment a bit misleading. The code enforces vault. Why this is related to the vulnerability does in the challenge. If the attacker will need to transfer token direct to the vault, not via deposit, A increase but S stay the same. Yeah, so that's the problem. And then flash loan will revert with invalid balance. Attacker can therefore break the flash simply sending token to the vault. That's exactly the behavior exploiting the challenge. What to do instead? Don't rely on S equal A unless your vote truly must be one-to-one. Block direct transfer for the vault. Yeah, that was something I did to say. Yeah, you can block any transfer directly to the vault. Token that supports hooks O by making the asset token not transferable to the vault. Use a different invariant. Check that detects only the condition you need to protect. What's the expected invariant? So track accounting properly using share price. If you want, I can show. No, in proposed implementation safer. No. So yeah, so they implemented that wrong. They tried to do something and forgot that can break everything. Yes, nice. Okay, do we solve that? It's solved. And let me just check. And save again. Wait. Save again. And finish the line. So I think tomorrow, I don't know if tomorrow I'm gonna be here. But the next live we're gonna try the second one. So yes, they passed because we break what they call flash loan, and they call balance off, and you see the balance off that has 10 more now, and then they're gonna give invalid balance here, breaking everything because we modify that one. Without converting and modify that one. So I want to call the deposit and make that works, but I don't know why that works. But the deposit should be working if that's implemented correctly. And with the deposit working correctly, they should be minting shares, and because the mint also gonna upgrade the total supply because it's a token, you can see here. So the values are gonna be the same if that's one by one. Yeah, in that case, the vault it's giving one token to one token, so that should be fine if people use the deposit function. And you kind of cannot avoid direct transfer for the vault, I think. No, in true you can, because you can put a hook in the token, not allowing transfer to the vault directly. I think it's possible, but should be not a good pattern, I think. Right. Very nice. So the next one gonna be, okay, solve. That's the answer, right? So let's see the answer. That's the answer. No, they don't have the answer here. Here you put the answer. So okay. Yeah, so the next one, let me know if you like that challenging. We do live stream. But the next one is gonna be nice naive receiver. That should be easy if they don't change too much and do a lot of stuff. So we learn also about a little more about the vaults and the patterns, right? So thank you for watch, and it's gonna be nice later see what the cloud code can solve that stuff. I think they easily can solve that stuff. So again, thank you novamente, eu ia falar português. Thank you again, and see ya in the next slide.